In this video, we are going to see one more example of writing an algebraic fraction as a sum of partial fractions. This case is a little bit more complicated because we have three linear factors in the denominator and two of them are the same, namely we have x plus 3 squared. So when we try to decompose this as a sum of partial fractions, we are going to write this following. We have negative 3x minus 4 over x plus 2 times x plus 3 squared. And we are going to aim at writing this as a sum of three fractions. One of them is going to have x plus 2 as the denominator. The next one is going to have x plus 3. And the next one is going to have x plus 3 squared. If instead of having x plus 3 squared we had a cube, then we'll have to write the three powers up to get to x plus 3 cubed. So we'll have x plus 3 squared, and x plus 3 cubed. But in general, we are going to see examples where we have a linear factor squared, and then we need to open up this to two fractions, one with the denominator, the linear factor, and the other with the denominator, the linear factor squared. And we do this in this way because what we wish to have in the denominators are just numbers a, b, and c. So a, b, c belong to the real. And this is an identity. So we wish to find a, b, and c, verifying that. So what we need to do is to redo the process of finding the common denominator. For the first fraction, a is going to be multiplied by x plus 3 squared because that's what is missing from the common denominator. b is going to be multiplied by x plus 2, but also by one more copy of x plus 3. And then c is going to be multiplied by x plus 2 only. And the denominator, I write it as well, x plus 2 times x plus 3 squared. So we need the numerators to be identical polynomials. So we need a times x plus 3 squared plus b times x plus 2 times x plus 3 plus c times x plus 2. So we need to expand each of the terms and we will get the following. We have multiplying a, x squared plus 6x plus 9, and then multiplying b, x squared plus 5x plus 6, and then we can already apply this distributive to get 6cx plus 2c. And now this is ax squared plus 6ax plus 9a plus bx squared plus 5bx plus 6b plus cx plus 2c. And this is if we write in terms of x squared, x in independent terms, a plus b times x squared plus 6a plus 5b plus c times x plus 9a plus 6b plus 2c. And this is the polynomial that has to be negative 3x minus 4. This means that the system of equations we are trying to solve is a plus b has to be 0, 6a plus 5b plus c has to be negative 3, and 9a plus 6b plus 2c is equal to negative 4. We can use the calculator for this and we can find that a is equal to 2, b is equal to negative 2, and c is equal to negative 5. So that means that the composition we are trying to write, substituting the values of a, b, and c, is going to be 2 over x plus 2 plus negative 2 over x plus 3 plus negative 5 over x plus 3 squared.